Hi, welcome to my YouTube channel. In this video, I'll be discussing about the priority queues. After that, we are left with only set maps and unordered set and maps. So after that, we'll be moving on to our new technology. So let's start with the priority queues. Okay. So priority queues are nothing but it does not have a unique order of insertion and deletion of elements. For example, it is also a queue but a special type of queue. For example, in queue we are inserting elements at the rear and deleting elements from the front, right? But here whenever we are going to delete an element, whatever the element, and one more thing, in priority queue we are having two different type, that is maximum and minimum. So first let us discuss what is maximum priority queue and minimum priority queue. So maximum priority queue is whenever we are going to insert a n number of elements into a queue. So first, whatever the highest element present in a queue is present at the top. So first, if we are popping our element, so whatever the highest element present in our queue will be popped out. So I'll show you example that you will clearly understand. So similarly, if in the case of minimum mini heap, so we'll get the value which is minimum in the range of 1 to n. Okay, so that's it. And syntax is a little bit different from maximum and minimum. And one more thing I want to share is the default uh, initialization is maximum. If I want to get the value of minimum in the range of 1 to n, we are going to write another syntax for that. So that we'll be discussing in this video. So let's start that. So similarly, as we have included queue, we have to include queue. Okay, for that using namespace std and integer main. Okay, so first we have to include priority queue, right? Priority queue, and after that this is my integer data type. And let us say that this is his maximum, because I have said that default is maximum, right? So whenever I'm going to insert 1 to n number of elements, the highest element present in my 1 to n range will be present at the top. So I'll show you. So this is my maximum, and after that let me push my elements. Max dot push 10 and max dot push, let me make it real quick. Okay, here I have inserted 1 to 10, 20, 90, 60 and 30 elements, right? So whenever I'm going to get the value, which is present at the top, that I'll be getting 90 because it is the highest value present in my max, right? So let us check that. So max dot top, and let us save that. Priority queue. Okay. So here we are going to get the value as 90 because this is our maximum heap, right? So if I'm using minimum heap, I'll be getting the value of 10, but this is my maximum heap. And not only that, if I want to get the total n number of elements in my uh, to show, if I want to show the total number of elements, I can't show you, right? Because in the form of like stack, it is not going, because I have to delete one element and I have to show that element, which is present at the top. So for that, for integer a in max, so first I'll have to pop, right? Max dot pop, and that after that, mm, I'll have to simply print that, right? C out of max dot uh, top, sorry. So let us check all my elements. So let us use this I less than m and I plus plus, and m equals to my mass dot size. Okay, I'll have to declare that. So yes, every time I'm going to delete, first 90 element is printed because that is present at the top. Okay, after that I have deleted the top element, right? So match the top get deleted. After I'm having four another elements. Okay, first this one gets deleted. Okay, after that I'm having 10, 20, 60 and 30, right? So I'll be getting the value as this is my second value that will be deleting, so that I'm going to get because that will be present at the top. So after that I'll be deleting 30 because it is at the top, and after that 20, and after that this 10 value. So that's why I'm going to get the value as first 90, 60, 30, 20 and 10. So that's how we are going to print values in my maximum heap. So if I want to go into the minimum heap, only the difference is declaration, and everything remaining part is same. So let's check that. Priority queue, and this is my integer, and for that I'll have to another line. This is my vector integer, and greater integer. So that's it. So let us say that this is my min. Okay, that's how we are going to declare minimum. Okay, so let us push that elements into my min dot push. Mm, let's go 100 like that. Okay, this is my 150 and this is my 50. Okay, push, and let us say that this is my let's keep it 0. Okay, so if I want to know what is the top element in my minimum queue, I mean priority queue, that I'll be getting as 0 because at the top this is my minimum heap, right? I mean minimum priority queue, so that I'll be getting the value of 0. So let me divide this border. So from here onwards we are going to get the value of minimum heap, right? So let me get the value of top value. Okay, C out min dot top, that's it, and this is my small handle. Okay, so these are my, yep, we got the value as 10 because in these 5 different values we are having the least value as 10, right? I have inserted 100, 150, 110, 0 and 109. Before that I have inserted another elements, but in minimum heap, I mean minimum priority queue, the minimum value present in the given inserted elements, that will be printing at the top. Okay, so that's why we are going to get the value as 0. So if I'm making this value as 10, that will be getting 10 because the minimum value present in it is 10. So that's it. For similarly we can print for this too also, and let me remove this and make it n. Okay, and that would be my min dot size because that's how we are going to find the size, right? And not only that, I'll have to change this also, and also pop each and every element after printing that. So that's it. Let's check what are the elements present in my min heap. Okay, so yes, first 10 gets printed because it is the least value, and after that 10 we are going to get the value as 109, right? So 109 we are going okay, 100, and after that 109, and then after 110, and then 150. So this is the simple definition and a simple understanding of how these two are working. So on a given data structure, I mean, how we are going to perform with the least time complexity and space complexity. For that reason, we are going to use this priority queues. A simple example is, if you want to know the large number of elements, and if you want to take the largest element, we have to take array and we have to traverse that, and it's a long process, right? But to know this in a single bit of line, we are going to use priority queues. So that's it. And if I want to know the least element from my priority queue, and we are going to perform that, and the order is unique, right? So first six, here 90 gets printed because the highest value, and after that removing, we are going to get the second highest value from that maximum value. Okay, so I hope you are clear with this topic. So if you have any questions, please do comment. And that's it for this video. In the next video, we'll be discussing about more topics in C++. So thank you.